Yeah, so I'm going to talk this morning mostly about the geospatial capabilities of AllegroGraph. We looked beforehand at the people that signed up for this seminar, and we saw that probably more than half come from the semantic web community, the people really familiar with RDF. And then there's a slightly smaller group that is from the geospatial community. And for them, shall explain a little bit more about our RDF triple store. So I thought before I go into my presentation, I talk just a little bit about why the RDF community needs geotemporal reasoning capabilities. If you now look at what RDF is doing on the web, you see that people are basically tagging most of the things that now happen in web pages also with say a little Google map or Yahoo map. So geotagging has become very, very common, and you also see it more and more in RDF projects. RDF projects are about people and their relationships and events that happen in space and time, so it's becoming more and more clear that reasoning about time and space really needs to be an integral part of the semantic web. Now, if you look at the geospatial community, you also see more and more interest in RDF because RDF is all about metadata. Sorry. And the tool that the geospatial people have right now is mostly about visualization or analytics, but not so much about storing metadata. One thing about metadata is that it's usually very unstructured and sparse, and you want to be able to keep adding more annotations and types of predicates all the time. So you need flexible technology for that. And then what you also see is that geospatial databases contain a lot of information that are not well described in relational databases because it's actually about objects and object hierarchies and about relationships between objects. So, for example, one thing that you see is that people start to use ontologies to describe geospatial objects. Just one really nice example is the National Map Project that uses ontologies to make it easier to take all the layers of information that they have in the databases and do queries that go through all the layers. So if you want to know more about this project, you have to go to nationalmap.gov. I will also be part of this discussion. Actually, there's a meeting next week about this. So I will be in the Washington area. And if there's people that want to talk about my presentation today, you can meet me in Washington early next week. So now let's go into the presentation. I will talk, for those people that are not so familiar with triple stores, a little bit about what you do with a triple store. I will show how you also can store events in a triple store, where events are defined as a combination of something that has a begin time and an end time, a location, probably some actors, and a type. I show how we can use one query language to combine reasoning over events. So we have this query language that combines geospatial, temporal, and social network analysis. And then I will talk mostly about geo after that. I will give a small geospatial tutorial that I've given before in one of the seminars. But then I will talk about two new things that we're working here at France. One is we show how you can, for example, play with a river network, a big graph, where we take some river network data from British Columbia. We do some graph search and spatial operations on that database. We output data in KML, and we can show it in Google Earth. So that's the first example. And then the second thing is a research direction. We have several customers that have talked to us about moving objects, tracking, say, tracking animals or soldiers or trucks or airplanes or even telecom mobile phone users, and if we can do something with that. So I'll talk about what we've done so far on this topic of moving objects. But okay, let's go into the basics of a triple store first. So for people that are mostly familiar with relational databases, a triple store is quite different. With a relational database, you begin with thinking hard about your data. Then you create schemas, and then once you've got your schemas and you've put them into your database, then you can start adding data and refining your schemas. With the triple store, you basically just open the triple store. This is I will show the first examples in how we do it in Python. So I create a triple store, seminar.db, and I'm ready. Then I can add some regular data. I can say that person 1 has a first name Steve, who is an organizer, and he's 52. I can tell something about myself. I say first name Jans is a psychologist and 50. And another person who's Craig, a salesperson, and 32. So what you see is I haven't added any schema data. I just entered data. I can say whatever I want. One distinguishing characteristic of a triple store is that one-to-many relationships are directly encoded. So I can say person 1 is a colleague of person 2 and person 1 is a colleague of person 3. And because I just want to say something, I say person 1 likes pizza. So now we have a bunch of triples, and actually these triples all together form a graph. So here you see our graph, which is our AllegroGraph browser. And what you see in here is the nodes that I created are the vertices, and then the edges are the links between the nodes. And on the left-hand side, you can see what the arrows mean. So, and you can just keep on adding data. Say another one-to-many relationship. Person 3 is a neighbor of person 1 and person 2. And now we see that there's some more relationships between person 1 and person 3. We have a query language. Well, we use the query language Sparkle. This is our internal language, but we can do the same thing as Sparkle, where we say select every X name and Y name, where X is a colleague of Y and not Y a neighbor of X, and X is a first name X name and Y is a first name Y name. So this is the typical kind of query you do with this type of database. Now, one other characteristic of triple stores is that they do reasoning, and this is the smallest reasoning tutorial on Earth. Basically, I say here that with this triple here, I say that every subject that has a predicate first name must be of type person. And if I add this triple to the database, then suddenly I see that person 3 and person 2 and person 1 are all of type person. Just by having this one little triple, I now suddenly have more information in my database. And then, because I want to lead on to the geospatial part, I can also put information about events. Say in my triple store, I can say there's an event 100 that is of RDF type meeting. I simplified the triples, by the way, for the RDF people that will say, hey, where are all the namespaces? You'll see the namespaces later, but I kept it simple for now. So I say event 100 is of type meeting. There's an active person 3 and there's an active person 2. And this event started at, well, at this particular time, and it ended at this particular time, and the location was in Berkeley. So we use latitudes and longitudes as pairs. We don't have separate triples for the longitude latitude. You can do that, of course, but we have an indexing scheme where we use them in pairs, a two-dimensional indexing scheme. And now you see here graph again, and you see that there's an event 100 that's related to person 2, person 3. It was a type meeting. This is the location, and this is the start and the end time. Yeah. So then, one of the things that we do, and one of the things why we get a lot of attention from people in the government, but also from marketeers, is we can do queries where we combine both temporal reasoning, spatial reasoning, and social network analysis. So we can take the query like, find a meeting that happened in July within 5 miles of Berkeley, was attended by the most important person, Janss's friend, the friends of friends,